Have you ever thought about how your washing machine works by itself? How traffic lights change automatically? How your smartphone quickly responds when you touch it? The answer behind all of these is a microcontroller. Welcome to this complete course on microcontroller and their applications, where we will go from basics to advanced real-time systems and 32-bit architectures. Hello everyone, I Dr. Mohammad Junaid Khan. In this course, we will learn microcontrollers step by step with theory, programming and practical applications. This course is perfect for B.Tech students, diploma students, competitive exam purposes, embedded system beginners. By the end of this course, you will be able to design real-world embedded systems. What is microcontroller basically? A microcontroller is a small computer on a single chip. It contains CPU, memory such as RAM and ROM, input-output ports, timers, communication modules. Unlike from a microprocessor, a microcontroller is designed for specific control tasks. Let me give you a roadmap of what we will cover in this course. Microcontrollers are everywhere, such as robotics, IoT devices, smart homes, automotive systems, medical devices. If you want to enter embedded systems, IoT and robotics, this subject is essential. Remember, in this course, you will be able to blink LEDs using assembly code, display numbers on LCD, read sensors using ADC, generate delays and timers, handle interrupts, build real-time embedded systems. In the future lectures, we will start with arithmetic and logical instructions in microcontrollers. We will also begin assembly language programming step by step. If you found this lecture helpful, so like the video, subscribe to the channel, press the bell icon. Don't forget to share with your friends. Now we come on today's lecture, basics of microcontrollers. Basically, I will cover all the topics in this lecture: introduction, microcontroller evolution, microcontroller types, criteria for choosing a microcontroller, real-time applications. Okay? In the unit number 1, 8-bit microcontroller, we will learn from this unit number 1 basics of microcontrollers, architecture of 8-bit microcontroller, pin diagram, memory organization, addressing modes. This unit will help you understand the fundamental structure and working of a microcontroller. In unit number 2, programming fundamentals. So we will learn from this unit arithmetic instructions, logical instructions, conditional control transfer, unconditional control transfer, basic assembly programming, software delay generation. This unit will help you understand how a microcontroller actually executes programs. In unit number 3, real-time control. This is the heart of embedded systems. Timers and counters, modes of timers, timer programming, serial transmission and reception, serial port programming, interrupts, external hardware interrupts, interrupt programming. This is where systems become real-time and responsive. In unit number 4, input-output interfacing. Here we connect hardware in this unit. 7-segment display, LCD interfacing, keyboard interfacing, ADC, analog to digital converter, DAC, digital to analog converter, memory interfacing, RAM as well as ROM. So you will learn how microcontrollers interact with the real world. From unit number 5, 32-bit microcontroller. This is the advanced microcontroller. Advanced concepts in this architecture, register organization, pipelining, operating modes, data processing instructions, data transfer instructions, control flow instructions, Cortex processor architecture. This prepares you for modern embedded systems like ARM microcontroller. Okay? For this microcontroller learning resources, textbooks, first textbook M. Mizuki Mastering 8051 Microcontroller Programming, a practical hands-on guide to approach using assembly language and embedded C. This is first edition 2023. Second textbook, A.Z. Dean Embedded Systems Fundamentals with ARM Cortex-M based microcontrollers, a practical approach. Nucleo F091RC second edition, ARM Education Media 2022. Reference book, A. Lutenberg, P. Gomez and E. Pernia, A Beginner's Guide to Designing Embedded System Applications on ARM Cortex-M Microcontroller, ARM Education Media 2022. Importance of microcontroller. Real-life examples are given in this slide. Let's understand how important microcontrollers are in our daily life. Today, there is almost no electronic gadget in the world that works without a microcontroller. Yes, you heard that right. Almost everything around you has a microcontroller inside. Personal information products you can see here in this slide. Let's look at some common examples of personal devices. First of all, smartphones, control apps, touch, communications. Calculators perform fast arithmetic operations. Smartwatch track health and notifications. Pagers receive wireless messages. Sound recorders record and process audio. All these devices use microcontrollers to process data and control operations. Now, let's move to laptop related devices. You can see in this slide, right? Wireless mouse tracks movement and sends signals. Keyboard detects key presses. Wi-Fi router manage internet communication. Pen drive USB, right, stores and transfer data. Each of these components has a microcontroller that helps it function intelligently. So, what does a microcontroller actually do? It acts like a brain inside the device, such as takes input, processes data, gives output. That's why microcontrollers are called the heart of embedded systems. So next time when you use any electronic device, remember there is a microcontroller working behind the scenes. In the future lectures, we will start learning how these microcontrollers are programmed. Microcontrollers in home and industry, right? In home appliances, now let's look at how microcontrollers are used in our homes. Almost every home appliance today is controlled by a microcontroller. A smart TV manages display, apps and remote control. Microwave oven controls temperature, timing and cooking modes. Refrigerator maintains cooling sensors and automatic defrost. Washing machine controls washing cycles, water level and timing. These devices are not just machines anymore, they are smart systems for industrial equipment. Now let's move to industries where microcontrollers play an even bigger role. Robotic arms used in manufacturing and automation. Assembly line systems control production processes. Conveyor belt systems manage movement of goods. Food processing machines ensure speed, accuracy and quality. In industries, microcontrollers help achieve high precision, automation, reduced human effort, increased productivity. So, whether it is your home or a large factory, microcontrollers act as the brain behind every automated system. Conclusion of this, that's why microcontrollers are everywhere from small home devices to large industries. Now, we come on the important point. What is a microprocessor? Now let's understand another important concept, the microprocessor. A microprocessor is an integrated circuit, that is IC, that performs all the functions of a CPU, central processing unit of a computer. Right? A microprocessor mainly includes ALU, arithmetic logic unit, you can see right in this slide, this performs calculations, right? Control unit controls all operations. Registers registers store temporary data. These three together form the core of processing, right? Important point of this, but there is one very important thing to remember. A microprocessor does not have RAM, ROM, input-output ports, so it always requires external components to work. For example, some popular example of microprocessors are Intel x86 family, Motorola 680 Cross 0, Pentium series, Intel Core i3, i5, i7. These are commonly used in computers and laptops. Okay, microprocessor, we can say only the CPU, right? A microcontroller means CPU plus memory plus input output all in one chip. That is the main difference of this microprocessor and microcontroller. So microprocessors are powerful but depend on external hardware, while microcontrollers are compact and self-contained. Okay? Yes. Microcontroller. A microcontroller is a small computer on a single VLSI integrated circuit chip, right? CPU, on-chip RAM, ROM, input-output port, timers, serial communication ports, ADC, etc. Right? Example Motorola 6811, Intel 8051, Zylox Z8, and PIC microcontroller 16X, MSP 430, and ARM microcontroller. Okay, number of controllers available in the market. This is the ICs, and this is just showing the IC. So this is the single chip. You can see here. This is the single chip. That is the microcontroller. This microcontroller contains all the things in a single chip, right? Not use external things here, right? Okay, now we come on evolution. In the year 1976, Motorola introduced microprocessor based computer, right, using 6800 microprocessor with certain add-on chips. Okay, this paved the way for the new revolution in the history of chip design and gave birth to a new entity called microcontroller, right? The Intel bagged the credit of producing the first microcontroller 8048 with a CPU and 1 KB of EEPROM, 64 bytes of RAM, an 8-bit timer, and 27 input-output pins in 1976. Then followed the most popular controller 8051 in the year 1980 with 4K bytes of ROM, 128 bytes of RAM, a serial port, two 16-bit microcontrollers, and 32 input-output pins. Okay? The 8051 family has many additional and improvements over the year and remains almost sought after tool for today's circuit designers, right? The same Intel introduced a 16-bit microcontroller 8096 in the year 1982. Later, Intel introduced 80C196 series of 16-bit microcontrollers for mainly industrial applications. Microchip, another company, has introduced a microcontroller PIC 16C64 and 8-bit in the year 1985. 32-bit microcontrollers have been developed by IBM and Motorola. MPC 505 is a 32-bit RISC controller of Motorola, right? The 403ZA is a 32-bit RISC embedded controller of IBM. In recent times, ARM company Advanced RISC Machines has developed and introduced 32-bit controllers which are high-end application devices, especially communication devices like mobiles, iPods, etc. Types of the microcontroller, right? Microcontrollers available in the market. So first of all, we will see here bits and how many bits. The 4-bit microcontrollers available, 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontrollers, right? The memory devices, embedded memory, right? External memory, right? These are the things available, right? So family name of this basically the 8051, right? Motorola, PIC, Hitachi, Texa, ARM, others, right? In 8051, the availability of this companies basically Intel also produced this one, Philips also, Atmel, Siemens, and Dallas, right? In the other thing, instruction set, two types of instructions available, RISC or CISC. RISC means reduce instruction set computer. Complex, this is the CISC, complex instruction set computer, right? Two types of architecture available in this controllers. First, Harvard and Princeton. Okay, we will see discuss in the detail in future slides, right? So now we will see the memory architectures, right? So von Neumann versus Harvard, right? You can see here in this slide. Let's quickly understand two important memory architectures used in microcontrollers and processors. So first of all, von Neumann architecture, right? In von Neumann architecture, single memory is used for both program as well as data. Okay. Same bus is used for instructions and data transfer. This makes the design simple and low cost, but it is slower because data and instructions cannot be accessed at the same time. You can see here, है ना, this one. Hardware architecture. In hardware architecture, separate memory for programming and data, separate buses for each. You can see here, है ना? This is for the program memory, right? This is for the data memory. So number of buses are using here, right? This allows simultaneous access, making it faster and more efficient, right? So we can say just a quick difference between this. Von Neumann means one memory, simple but slower, right? Harvard, that is separate memory, complex but faster. Okay. So most modern microcontrollers use Harvard architecture for better performance. Okay. Memory architectures we have little bit learned in the previous slide. In this slide we have this is the feature, one column of the feature, second column of the pincetron. Pincetron, that is the von Neumann, both are the same thing, and this is the third column. So one by one we will see what is the difference between these architectures, right? First of all, we can define here the memory, right? Okay. So here we can use the single memory. This is the memory in the shared base. Okay. But here the separate instructions and data, right? For the feature bus, one bus available here, so we can share the bus also in this, right? Von Neumann. In the Harvard, two buses, separate buses available, one for data, one for instructions. Okay. Access for the von Neumann sequential here, right? But here the parallel. That means we can say the slower. This is the slower as compared to this. Speed slower this one, and this is the faster, right? Complexity, this one is simple, only one wire is required, right? But this is the more complex as compared to this. Used in PCs, this von Neumann architecture is used in PCs and general computing, okay? But hardware used for the microcontrollers and DSP, okay? Now we come on the criteria for choosing a microcontroller. So we will see these criteria for finding the microcontroller, right? First, application requirement. Second, processing power. Third, memory requirement. Fourth, power consumption. Fifth, input, output and peripherals. Next, connectivity. Next, package and size. Cost and availability. Next, development tools and ecosystem. Next, security features. Next, reliability and certification. Right? This is the criteria for choosing a microcontroller, right? So we can decide as per these things. Okay. Now we come on the 8051 family comparison, right? Four microcontrollers are there here. You see 8031, 8051, 8052, 8751, right? So these are the column of the feature, right? First of all, we can see the RAM in the bytes. Okay, this is the size of the RAM basically, है ना? So this is the 128, okay, byte, the RAM available in this microcontroller. In this microcontroller also given the 128, okay, 8052 also given the 128, 8751, that is also, this is the increase here, the RAM is increase here, just a double, right? ROM. ROM is not available in this microcontroller. If required the ROM, so you can use as an external, right? In 8051, that is the 4K byte ROM is available, right? In 8052, 8K byte, right? But 8751, that is the 4K byte UB EEPROM also available, right? Timers, so two timers available in this microcontroller, two timers available in this. Here only the three timers available in this, right? This microcontroller also has the two timers, right? Input output pins, 32 input output pins in all microcontrollers, right? Serial communication port 80511, all basically has the serial communication port 1. Okay. Interrupts also has the 6 interrupts in 3 microcontrollers 80316, 80516, 87516. Only change 8052 that has the 8 interrupt sources. Okay. The future of microcontrollers empowering smarter technology. Microcontrollers are evolving with increased integration of AI capabilities, right? And advanced wireless connectivity, driving innovation across various sectors. So these are the things: smart home automation, wearable technology, industrial automation, IIoT, right? Agriculture, healthcare, smart transportation, environmental monitoring, retail and supply chain. Okay. Now we come on the summary, right? The microprocessor and microcontroller definitions, right? We have seen in the previous slides. Microcontroller evolution already we have discussed. Microcontroller types, number of microcontroller types we have seen the previous slides. Criteria also we can discuss, and for choosing a microcontroller. Real time applications also we have seen in the previous slides. Okay, in the next class we will delve into the architecture of the 8051 microcontroller, where you will learn about its CPU, ports and on-chip resources, right? Now these are the simple questions of this related to this topic. Basically, differentiate microprocessor and microcontroller, right? This is the basic question of this unit, right? Control risk versus CISC, right? Definition von Neumann and Harvard architecture. What is the criteria for choosing a microcontroller? These are the 4 questions generally available in this unit, right? In this topic we can say. Now, a microcontroller may be small, but in the hands of a learner, it holds the power to build the future one real-time idea at a time. Thank you very much.